Nice. Yeah.
Okay, welcome everyone. I hope you're able to get me. And, okay. Are you able to get me? Okay. Oh, right. We're going to start. All right. Good evening once again. So we can start our lesson. Bon. Are you able to get me? Are you able to get me? Okay. There's a yes. Normally, I prefer when we're solving questions, we have all our mics turned on, but since it's at night, I'll let it be. Okay, so the first thing that we're going to look at is I just want to explain something a little bit on mineral, as people have received a lot of complaints towards the understanding of this. So I believe that we are going to get a concept right now. The next thing that we solve, I won't focus on that. So the people are going to miss, inshallah, they will understand at school. So I'm going to first look at that. So the concept is this: when you want to understand, if you want to understand measuring mineral, I'll use something comme ça, the x or y plane. So we have the y-axis, x-axis. So for example, if I was to get this part here, all the points that are in this part, voila, and I get a part that is here, down, voila, part comme ça. Automatically here we know that the part that we have here is positive. These are normally positive numbers, and the one that we have here are negative. That's the y-axis that is going that side. So for me to understand what concept I'm going to be using, and I'm looking at, for example, if I was to say A is less than or equal to grown M being the majorant. Ça veut dire que my majorant I'm going to be looking at, my majorant is this one here, and my mineral is that one there. So if I have this as my majorant, I'm looking at every simple object that can be contained in this set. And if I'm going to be looking at my mineral, I'm going to be looking at every, of course, a certain limit. So the limit that I'm having here is this point that is here. I don't know what point this is. I can call this my point A. And maybe this point that I'm going to be having here, I can call it my point B. So the mineral are every object that are found here, and my majorant are every object that are found here. Ça veut dire que because we have less than here or equal to, I'm going to look at the highest value and the least values that we can have. So if I'm going to be looking at my majorant, I'm going to have an open interval because that's my highest value, which is A. Okay, it's going to where? It's going up to a certain number that I may not understand. And what value is that going to be? Am I speaking to myself?
It's going to be infinity.
Infinity. So I'm going to be looking at it going to positive infinity. And we are going to open up the set comme ça. C'est la même chose qui va appliquer for B. So for B, we're going to look at it, okay, the highest value I'm having here in this range, for example, we are having a certain value up to negative infinity, because this can be going down. Pardon me, my M is going to be focused here. So you are going to have a point B, which is the most focused point. That will be our most focused point, and they're going to open up, and they're going to go up to negative infinity, and you open up, comme ça. So you open up. This is why we are saying normally when we're finding the majorant and minorant, we use this is because we're looking at every tiny object that is contained in a situation like this one in this set. So this is why we use this rule every time when we're representing majorant and minorant. So that's just a general concept. So when you're looking at the majorant, you're looking at every tiny object using Starting with the highest value that you've been given, you close it up to the infinity, extend infinity that you don't know of. The mineral, the meme shows the lowest value you've been given, moving to the lowest or the least infinity that you can be having, which is contained in this set that you have over here. So that's the general concept that we have for majora and minora. Okay, so every time you are going to be solving this, just come about with this. Come about to think about this part here. As long as you are able to get this part, able to apply it, it's going to be very, very simple for you. Voila, this is the most important part. So this is the general concept for majora and minora. Okay, voila. So that's the part that I wanted to explain on majora and minora. Okay. Do you have any questions? Any questions?
Can you please repeat?
Okay. Let me just work everything. Okay. So I was trying to answer your question that I've been receiving of late, and the question was to do why have we been using the intervals, well, like we want to call them, or the open and close bracket when you're finding majora and minora. So in actual sense, we can have, for example, an interval here comes up. We have an interval A less than or equal to ground M, which is your majora, less than or equal to petite m. Okay, so I'm going to use the x or y plane, which is here. So I'm going to have, for example, the highest value that I'm going to be having here, I'll call them my majora. And some certain values that are going to be pointing to the negative, I'm going to call them my minora. So what's the concept of majora? Majora, I focus myself on every tiny object that is found here, knowing that every tiny object is found here is what? It's positive, n'est-ce pas? We can have any tiny object can be found here, which is positive. And here, my minora, I focus more on the highest positive value I can have up to the lowest value I can have, which is negative infinity in this actual sense, and my highest positive value I can have is positive infinity. So how do I come up with making, for example, like a set that I've been coming up with? So in this case, I have every tiny object that is here. I'm representing this by A. I have every tiny object that is here up to positive infinity. What is your highest object or number that you can have, for example, that can be contained in this set? I focus myself, which is probably, maybe I can say, okay, my highest focus point that I'm having is this point here, which is maybe A. Pardon. This point, which is A. So I'm going to say A, close bracket, equal close bracket, because it's the highest point you're focusing on. Okay. Up to what? I've got a lot of tiny objects that I cannot even manage to count. DK, let me use my positive infinity, the tiny objects that I'm going to be having, tiny digits that I'm going to be having here. I open the set that are uncountable, okay? But they can be, because here you can have maybe A.001, A.002, A.003, but instead of you saying A.0000001, you use positive infinity because A is not really a constant number here. It can be maybe this curve here can maybe A point something. No wonder, for example, in this case, if we have A, comme ça, ground M, this means that A is a defined number. That's why we have an equal sign here. A is less than. Ça veut dire que we have uncountable digits that can be included in this set, which is majorant. We have uncounted. So if you just give me the answer to be A, mean that you have not focused on this other equality sign that we have here, which is the less than. That's why we add the positive infinity, because of this equality sign that we're having here. If you just give me A to be your specific answer, mean that I have not used the equality sign that you have, which is the less than here. Okay, so every tiny object that you're having, which is up to the positive infinity, c'est la même chose that you're going to apply for example, maybe I say B, being your highest element up to negative infinity, which you are going to be having. Meaning you have the negative possible digits that you can have contained in this set, and that's how we find your minorat, normalement. Donc ici, avec cette définition, we are going to say M is less than or equal to A. You have dealt less than here, which you have dealt is 1, pardon, it's B here, possible B. And the equal to that you have dealt with here is this B that you have here. So you have finally brought about your minora, and you have finally brought about your majorant. So look at these two signs here. If you just give me the answer to be A, impossible, mean that you have excluded a certain inequality sign that you have here. You have to include it here. So how do you include it? You look at the set, you have got positive tiny objects up to positive infinity. You look at this inequality sign, you have got the least possible values that you can be having, which is up to negative infinity. And voila, you establish your what? Your majorant and your minorat. That's the simplest concept that you can actually have. That's just a general recap on what I wanted to tell you about the majorant et minorat. Donc, s'il vous plaît, attention avec ça. You have that and you have that. You just don't leave them just like that and say, no, I just focus on this, the contained digit, which is just the equal sign. You have to look at also another inequality that you have here, the less than and the greater than. Okay? Is that very, very clear? Because you're going to be using a lot of this when you're going to be looking at suites or sequences in English. So if you don't understand this concept that is here, it's going to be very, very difficult for you, because when you start looking at suites, you're going to establish that every point that you'll be having here is delivered in a what? A suite. It's a sequence. Everything happening here is a sequence. Everything that is happening here is a sequence. So I'm going to give you a certain sequence and say, what is happening here? Do we have a majorant in this sequence? Mean that is the sequence increasing or the sequence is decreasing? You have to know that concept. You have to learn to derive everything that's going to be happening. So you have your hand up. Wait.
My question is, in the minorat, can we have a positive number?
Oui. So we have a positive, for example, here, your B. I can have a positive number if you have, for example, you have it here, okay? Maybe the values that you've been given, maybe, for example, we say they are 0 and 1, okay? Like in the question, means that you're going to have quelque chose comme ça, n'est-ce pas? You're going to have your majorant, and you're going to have probably your minorat here, you see. So minorat, you look at every tiny object that is here. Majorant, you can also focus on the highest value object that you have here. But if, for example, it's starting from here, that's your minorat, eh bien, so this is a positive value. But of course, you have to look at the other values that you have in, which are listed here. Of course, put into mind to say, what set are you defining? Is it real numbers? Is it natural numbers? Is it integers? You have to also be very careful there. For example, if I give you a set that is not to do with maybe negative numbers, you shouldn't focus yourself on the negative numbers. Okay? Maybe, of course, that question again is going to come with extend limit. Normally, they will tell you don't include 0. Normally, that's how, to just explain the question, of course. But normally, that one comes with an expression of 0. So you can have positive numbers, but just don't be leaving out the range that you're going to be focusing on. Okay.
All right.
Sony, you end up again.
Yeah.
Oui. Yes. I'm unable to get you.
No, you have answered my question.
Okay. So is everything clear right now? Because I don't want you guys to have anything on that part, s'il vous plaît. If you're not clear, tell me. No, we haven't gotten the concept. I explained myself. This is a tuition, so I don't mind. Tell me. No, I'm not very clear there because it's very essential. I'm going to do it's a revision that we're doing here. So for the next thing that I'm going to focus on is on a different part. I'm not coming behind. And I made this lecture for you guys. So you have to make sure like you have really understood what is going on here. Okay.
Maybe the only thing that I would request for is maybe like if we have time, we can pass through the question that you gave us as an exercise, especially the one that you gave us.
The TD?
Yes, the TD, as in.
Yes. No,
They were.
yes, there are other questions. For the TD, we're going to continue. We're going to have a TD on Friday. On Friday, as far we'll continue solving those questions. Okay. C'est bon?
That question that you gave us for the TD, can you please try and just solve it? Since we'll be having other questions, we'll be solving other questions on Friday. Can you just please solve it?
No. For the TD part, I'll solve it. The TD is it's a TD. Here, I'm just going to do a general recap of some basics that you need. Okay, because the other people that are not here. So if I solve for you guys, they will come and complain on Friday to say, actually, you just said the revision, but how come you solve the question? Okay. So right now, I'm just going to focus on the second part so that you guys, when I solve together with you the TD, you get to understand. You understand better than those that are not going to attend the class that I'm having. So I'm not going to solve the TD today. Okay.
All right, boss.
All right. Renzu, I saw your hand up.
I'll use Olivia's phone. Mine has gotten
Okay.
I haven't gotten the one you're from explaining.
Okay, so I'll explain it. Okay, so I was saying we have, for example, I used a Cartesian plane. So we have, for example, you see, we have a certain number of digits up to the highest value probably that I can call my A. Putting to mind, every object is here is positive. And I can also have certain values here. Mind they might be ranging up to negative infinity. If maybe the highest point being made B or B, and this being your minora. So for us to define what majora is and what minora is, we have that have been given in the book. Majora. So we're looking at every object that is here. So how do I describe every tiny object that is here? I can describe this by using these inequality signs that we have here. We have an equal sign. An equal sign we're having here is where? It's showing us the point A, which is here. So I'm going to put my A. What do I do with an equal sign? I have to have a closed set. I've got an equality which is saying A. So A is my lowest value in this set, but what is my highest possible value I can have here? I can't have an object that is here. It is positive, meaning that my tiny object I can have here are up to positive what? Positive infinity. So I'm going to put my positive infinity. And what happens when you have positive infinity? You open the set, and that's my measure. Are you okay, Wenzu?
Yes.
The même application that we're going to have for B, we're going to say, oh, okay, my B what I'm having here, my highest value I'm having for my B is what? My measure here is what? Is my DK. This is my highest. So if it's my highest and I've got an equal sign here, close obligatoire, and voila. My highest, or rather my smallest digit that I can be having is up to where? It's up to the tiny, up to I don't know what is it, negative infinity. What happens when you have a negative infinity? You open the set. And voila, that's my mineral. Est-ce que c'est bon?
Oui, c'est bon.
J'espère. Okay, so this is what I wanted to explain on marginal mineral, because that's bone superior is very, very simple, because as long as you get your marginal mineral, you're able to find the bone superior. I think I've not found any, nobody has sent me a problem on bone superior and bone inferior. So I won't really focus on that. Okay, I gave you an exercise.
Yeah, when you ask for the bone superior and also for the le plus grand element, how are these two different from each other?
But normally they actually get to be the same, because normally when you have the major, you are going to find the bone superior, and if you have the bone superior, you are also going to have a highest value. But you just have to be careful with. When I said no, you have to be careful with what condition you have been given. Okay, for example, if you are given natural numbers, this has got a certain order. Every type of number has got a certain order. If you're given real numbers, you're going to have a certain order. Okay. For example, if I give you natural numbers and I tell you to say find the highest value, you can't find it because you have numbers up to positive infinity. Okay. But if you have a defined set for this, you're able to find the majora, you're able to find the bone superior, and because you have a defined set, you're able to find the true ground value. And true ground value normally more, you just have to look at the sequence, the set that you have been given. For example, in this case, you have A and B. You already have that. The highest value you're going to be having here is B. Okay. So you just have to look at the set. You have to concentrate on the set. But on the bone superior, you have to concentrate on your majora, the interval of the majora that you're having. Okay?
Oui.
Okay. Okay, now if there's no other question, we're going to solve question 4. So question. Yes.
I was asking about the bone inferior and the le plus petit element. How can we differentiate that?
It's the same thing that I'm from saying for the bone superior and majora. It's just the other way around. You're able to find the mineral, you're able to find the bone inferior. So you concentrate on the mineral. When you concentrate on the mineral, that's when you find the bone inferior. But the plus petit element, you concentrate on the interval that you're going to be having.
Also, just like the other one, we had the bone inferior, but we never had the plus petit element. So mainly we focus on the interval when for the plus petit element.
Voila, because you're looking at the what is the least object that you have been given in that same interval. It's like you're just counting on the interval. Okay. But bone inferior is the maximum minoran or interval of a minoran, a set of minoran. That's what that's the bone inferior. So when you're finding the bone inferior, you focus on what minoran you have been given.
Okay, thank you.
All right, you're welcome. All right. So the question that I'm going to be solving to you, these are actually things that we used to do in Zambia. So in Zambia, back at the back mathematics, we're looking at question 4. Okay, we're looking at this question here. There are people that have solved the question, but I'll tell you something. When you're solving analyze questions with just giving me x is equal to this, x is equal to this, it's wrong. Or rather, you lose marks. Normally, you have to be talking. So I try to solve these questions, and you see how I solve the questions. So the first question that I had here, what we had here is trouver tous les réels x tel que on a. So we have this, which is the modulus. I guess you did modulus with mono today. So we have modulus x minus 1 plus modulus of x minus 2, which is equal to 2. What is a modulus function? If we have modulus, for example, what's the modulus of x? This is equal to saying what?
Equal to x.
Equal to x. Once you we used to do these functions back home. If we have modulus x, ça veut dire quoi?
X squared.
We're going to have x squared. So have x squared, ça veut dire you're going to have negative values for x. Normally, if you have to find the square root and positive values of x. So already, when you have modulus of a function, you are going to be thinking of two values that are going to be given, which is a negative value and normally more a positive value. So already, when you have x minus 1 modulus, this is equal to what? It's equal to us saying what? X minus 1 what? I'm waiting for you guys. You can tell me. Murenga?
It's the same as x minus 1 squared. Okay.
Squared, plus, open bracket, x minus 2 squared, which is equal to 2.
Squared.
What are we finding? We're finding real of x, meaning that we're finding real numbers of x. And voila, you solve this equation that you have here. So try to solve it and give me the answer. Before you start solving, are you okay? Is it clear? Is it clear? Any questions
Yes.
here? So try to solve it and give me an answer. I'll give you 3 minutes to solve it. Very, very simple. answers? What are the answers? Anybody found the answers? Oui, Ruben. We four. What are the answers?
Yeah.
What advice did you find?
Not really. I'm just from joining and I'm kind of lagging. I don't know what's going on as in the expression that you've done. Yeah, the modulus part there.
Okay, so we said we're looking at the modulus function. We are taught to say find all the possible values of x such that modulus of x minus 1 plus modulus of x minus 2 is equal to 2. So we define modulus of function to be equal to x squared. So if I to find the values of x, we're going to have two roots of x, meaning that we're going to have a negative and a positive. Not specifically just a negative or positive, meaning that there is something that is least and that is a plus grand, a dot. So in this case, we have x minus 1. We change this to become in the form of this, and we have x minus 1 squared plus, we also change this one, we have x minus 2 squared, which is equal to 2. So I said find the values of x, the possible values of x that we can have. TK, your hand was up.
I think the value is 3 minus 3 squared. 3 minus square root of 3 over 2 for x1, and then x2 being 3 plus the square root of 3 over 2.
Can you find the original digits? Put them in a fraction form.
I put them in a fraction form?
Yeah, put them in a fraction form.
Okay.
Are we all solving? Cake and dot? It's very, very important that you practice on solving the things. Otherwise, you think you're getting the things, but it's not really the case.
I found x to be the square root of negative 3 over 2.
Not of negative 3?
Over 2.
Okay. That's a different answer. So we have two different answers, okay? Any other answers?
I found mine to be a decimal.
Decimal. Try to put in a fraction. Put the decimal in a fraction.
I found it. The first one is 6 plus. Oh, yeah. 3 plus the root of 12. The other one 3 minus the root of 12.
Okay. We have any answers? Yeah.
Me, I found that it's x is is equal to the square root of 7 over 2.
Square root of 7 over 2. Okay. What's the square root of 7? Okay. Well, these are my responses. Or rather, we can solve it together. Okay. So we are going to start with this part, x minus 1 squared. The difference of two squares, this is equal to what? I'll just be pointing. Actually, what's the answer here? X minus 1 squared is equal to saying what?
That should be x squared plus x squared minus 1. Is it
X squared minus 1?
Yeah, x squared, yeah, it's x squared plus
How about x squared minus 2x plus 1?
Okay. No. X squared minus 2x plus 1. Okay, très bien. And x minus 2 squared, this one is equal to what?
X squared.
Pardon, just a minute. TK, you have your hand up, oui.
X squared minus 4x plus 4.
X squared minus 4x
Plus 4.
plus 4. Okay. So we have ça, c'est déjà trouvé, et ça, c'est déjà trouvé. So we're going to have x squared, squared minus 2x plus 1. And we have a positive here, so we're going to we just put this in brackets. On va avoir positive here, it's going to be positive. We're going to have plus x squared minus 4x plus 4, which is equal to 2. Okay, so we have 1 plus 4, we're going to have 5. So we take the 5 that side, we're going to have 2 minus 5. So we're going to have 2x squared, 2x squared minus 6x. 1 plus 5, 1 plus 4, 5, 2 minus 3. So we are going to have plus 3, which is equal to 0. Okay, we all arrived here.
Yes.
Yes.
Okay, so for those that arrived here, I mean that your answers must be correct. So you just have to solve this function that we have here. And the x that you got here was what? The first x was what?
I found 3 plus the root of 12.
3 plus the root of 12. And the other one?
The other one is we're just going to change the sign, which will be 3 minus the root of 12.
Okay, correct.
Sorry, is that 2x squared minus 6x plus 3 or plus 5?
No, it's plus 3. It's not 5 because we have 1 plus 4, which is 5. The 5 goes this way. We're going to have 2 minus 5, which is negative 3. Then the negative 3 comes, is going to positive 3.
Oh, okay.
Okay. All right. And voila. These are the responses that you have.
Sorry. From the part where you had positive 1 plus x squared minus 4x plus 4. Is that positive 1 and negative 1?
Positive 1 and negative 1. Positive 1. We have x squared minus 1 plus x squared minus 4x plus 4, which is equal to 2.
So that's a positive 1. I was asking why you have x minus 2.
Wait.
That's a positive 1.
Yes, it's positive 1. I got it from here. It's this one which is here.
Yeah.
You solve this.
I wanted to ask, like, since we're not supposed to group the positive 1 and the positive 4, since they have like terms.
We did. No, we have positive 1 here and positive 4. These are like terms. So what you do with like terms, you solve them. Something that we have the x squared and x squared. We solved it here. We have 2x. We have negative 2x and negative 4x. We solved it and we had minus terms. So 1 plus 4 is 5. We took the 5 this side. We had 2 minus 5, negative 3. So I got the negative 3 and brought it here. This is my positive 3 here, and this side remains 0.
Okay. Thank you.
You're welcome. TK, you had your hand up?
Is that the final answer? 3 plus the square root of 12, and then 3 minus the square root of 12.
Bon, I'm not with the calculator right now, so I can't really tell what value you can go for square root of 12.
But when I solved, I got something else, but I'm not sure. I don't know if you could verify if that is the answer.
But I prefer you leave it in fraction form. So I didn't get what you said.
I was saying yes. We'd still leave it in fraction form, but I don't know if is that. Could you like verify if you don't mind?
Yeah, so I was saying it's better actually leave it in fraction form. So you find the square root of 12, and then you say plus 3 plus the square root of 12 that you find, and then you put in fractions. Actually, you don't leave it in the square form. I prefer leave it in. I don't have a calculator right now, so if somebody can find square root of 12, then you can leave it in a fraction form.
Can you please repeat? Not the whole thing. From 2x squared minus 6x plus 3 equals 0.
Okay, so here we have x squared and x squared. So we said x squared plus x squared 2x. Bon, okay. Since we are clear here, we find what do you call it from back home? Bon, I think we all know this from here, n'est-ce pas? This must be familiar with this. So we have our A, our B, and our C. And that's what you just put here. You put your, I just forgotten what you call this from back home.
Wait, sorry.
So
It's
this is what
supposed to
you've used
be
for us.
negative B, not just B.
Negative B.
Yes.
Negative B. C'est bon. Negative B. Merci beaucoup. So that's how we put in two, here, and then voila, to come up with the answers. So the question we ask, you can try to fit in your A being 2, your B being 6, and your C being 3, and then you have to come up to probably this answer that you give me. Okay, we have Paul. Paul, your hand is up.
Yeah, like I want to find out how the guy that answered had arrived at x plus the root of 12, and the other one x is equals to 3 minus the root of 12. Because I also arrived at a stage where it was negative 6 plus or minus the root of 12 over 24. But from there, I'm getting confused on how we dropped to these two answers.
There are some complications there. Actually, I thought it was there. Okay.
Wait, can I say something?
Sorry?
Okay, I use the same formula, but the 3 plus square root of 12, I'm not getting that one, except I'm having 3 plus the root of 3 over 2 and 3 minus the root of 3 over 2. So I'm also not sure where this square root of 12, 3 minus square root of 12 is coming from without any over something. Like it's not in fraction form or something. Yeah.
Yeah, because even me, I got over 2, but I don't know how he got himself without anything over it.
So if you guys have done, if you do your calculations right, are you finding x to be equal to 2.3? I just don't have my calculator right now. No, we have to be very, very sure there, or rather certain. We must be very, very certain the value that we find here. So you're the people to correct me. So is everybody finding square root of 3 over 2? 12. All right. Then probably maybe our brother made an error. It's supposed to be square root of 3 over 12 over 2, pardon. Okay. Probably just made an error. C'est bon? Est-ce que c'est bon?
Oui, c'est bon.
Okay. C'est très bien. So the next time that we're going to, when you do functions, I'm going to solve this same question. You should remind me. We'll solve this same function, but we'll solve it in a very, very different way on a complex level. Okay. So I just made it a general way. Normally, I tend to solve it like the way we solve it back, but when you start looking at functions, we're going to have different ways on how we're going to solve that function. When you look at the function, aidez-moi. What other function they give you? Okay, I don't know if you guys are able to get me. Est-ce qu'on est là?
Oui.
Okay, Fabien. Okay, we're going to solve question 3. Question 3 is very, very complex. So we have déterminer les ensembles suivants. Bon, just before that, in the inbox right now on the chat, how many of you already understand what real numbers, natural numbers, integers are? Be very, very sincere. Just write in my inbox on our chat, on the same chat. Just write moi, so that I'm clear, so that we can work out this question. Okay, I want to know. I need to know, like, okay, the coup has been already understood. I'll just suppose that at least we've gotten the general concept of what real numbers are, and we're able to solve this question. The question is déterminer les ensembles suivants, mettre ces ensembles sous la forme d'un intervalle de R ou une réunion des intervalles. Okay, so we're going to solve the following. So for A1, which is equal to X, and this X belongs to real numbers, and we put this under a form of an interval of R or a reunion of intervals. Reunion of intervals means that you can put in like a reunion, you put it in a union set. Okay. I think I saw in the group Mono had sent you guys quelque chose comme ça. She described the real numbers. For example, every time you come across quelque chose comme ça. Okay, so we have, first thing that you have to look at when you are solving such questions is you have to ask yourself, what's a real number? How do you define a real number? So we define a real number by us looking at all total elements of negative infinity up to positive infinity. So every number that we're going to be focusing on, we're going to be looking at all those initiated elements, and these that are the elements that are contained here are what we're going to be assuming as the real numbers. So this is a defined set of a real number. It's negative infinity to positive infinity. Those are the real numbers. Those are the defined sets of real numbers. Very, very important that you get the concept. Every time you are given a question, you have been given natural numbers, you have to know what are my range of natural numbers and am I going to be focusing on. To get integers, you have to know what are my range of integers that I'm going to be focusing on. The first thing you have to look at in this question is, I'm looking at real numbers. So what are real numbers? Real numbers already you put to mind, I'm focusing on what? I'm focusing on negative numbers running to negative infinity and numbers running to what? To positive infinity. That's going to be my focus. Okay, so I can find any number in this range that I'm having here. We have something very, very important here. R et toi. Okay, R et toi, ça veut dire quoi? If we have R et toi, okay, we concentrate on numbers that are going to be ranging, real numbers. We're going to focus on numbers except 0 up to positive infinity. Bon, normalement, for example, if we call these positive numbers, we say R est positive. So we're going to be looking at except 0. Why except 0? Because if we have a set comme ça, this automatically will mean maybe our x is greater than 0. This means that x is not equal to 0, but x can be any number that is after 0 and is greater than 0. This is what it means. Okay, you have to be very, very careful every time you're going to be describing such types of sets. Okay, so it's very, very essential. You have R et toi, ça veut dire que your x, for example, in this case, your x must not be equal to 0. So you can focus on any other types of numbers you can be having, but your x must not be equal to 0. Très, très, très important. Okay. Someone has asked the question, what is the difference between complex numbers and real numbers? Complex numbers are numbers that are represented by the form. For example, if you have x minus 1, we all know this general form. No, is it positive here? Yeah, it's positive. Is equal to 0. When you have x squared to be equal to negative 1. So what's the square root of negative 1? It's equal to what? It's equal to I. Those are complex numbers, sure. Let's not ask the question. So complex numbers, these are complex numbers. These are numbers that you have an identified object, which is negative 1, square root of negative 1. We are going to be equal to I. Those are complex numbers. Okay. So don't confuse real numbers and complex numbers. Real numbers don't have an I. We have defined numbers. Okay. Derrière, I don't show. Okay. Are we okay? So, are we okay with the real numbers? Do we now know what real numbers are?
Yes.
Oui, c'est pas grave. Okay. Okay. We're doing it online. So if you keep quiet, sometimes I think I'm just talking to myself. So yeah, just help me by giving me a feedback. So yeah, we're okay. Okay. Yeah, it will really help. So normally in Analyse, you do a lot of real numbers and natural numbers and complex numbers. Complex numbers, you do a lot of it in algebra, but you just have to understand. Starting with the real numbers. So, do we all understand the question? If you don't understand the question, ask me, s'il vous plaît. Do we all understand this question? Okay. So the question is déterminer les ensembles suivants. Maîtresses. So we determine A1. A1 that has been given here is x belongs to real numbers and x squared is less than 1. So we determine all possible states, or rather all possible values that we can have for x when you have an equation comme ça that we have here. And you should put them under an interval of real numbers. Okay, so it's like you are determining all the values of x that you can have and you put them in an interval of r. Or if you want, you can put them under a reunion of intervals. That's what we've been told to do in that question. So what's the way forward? We look at question 1. Well, we focus on this one. Cette question. What's the first thing that you think we should do here? What comes out? What comes up if we have A1? How can it be? What kind of values can we have for x? What set do we have there? It's very, very simple. Just look at it. What kind of set do we have here for x squared is less than 1? Find the values of x. We are going to solve for x. So we are going to have x squared is less than 1. How do you find the values of x there?
You're going to have to square root on both sides.
Très bien. We square root this part. We're going to have the square root of 1. So we're going to have x is less than, what's the square root of 1?
It's 1.
1.
Plus
so,
or minus.
Plus or minus 1. So how do you write an interval, or how do you write a set or union of this? we're going to have a union of -1 and +1. And voila, that's your answer for A1. Very, very simple. Est-ce que c'est bon?
Oui, c'est bon.
Alors, find A2. The girls, I've not heard any compliment from the girls with this question. Are we okay there?
Yes, sir.
All right. So you guys solve A2. I'm waiting for the responses.
X is less than 1.
Somebody said, well, okay, I'll give you 3 minutes so that others are given number time to solve. Well, Analyse is saying, okay. All right. Well, I'll prefer you tell me, where didn't you understand? Those part I haven't understood. You tell me, I haven't understood. I've explained a lot of things, so if you just say no, the message is coming very late, so I don't know which
Kindly
part.
repeat. I haven't understood.
All right. For the question, when I was solving the question.
Yes, the question, A1.
All right. So for the question, we have x squared. So we are told to say we find any possible value of x that we're going to be having here. What's the possible values of x that we can have here? So we have a function, which is x squared, which is less than 1. So since we are finding the possible values of x, mean that we should find the exact value. No, not the exact values, because we're having a less singularity sign that we have here. So mean that we're going to find any possible value of x. Okay. So how do we find the possible values of x? We square root everything. The right hand side and the left hand side. When we square root this, we're going to have x, which is less than the square root of 1. And that's the square root of 1. The square root of 1 is negative or positive 1. So we're going to have x, which is less than -1, or x, which is greater than positive 1. We put this in the form of a set. We're going to have -1 and positive 1. Open. Why we open is because we have got this inequality sign that we have here. Okay, so you can't have a closed set. C'est bon?
Oui.
Okay. Somebody's hand is up. Yes, TK.
Is the answer for A2? A2. Yes, A2. Is it?
What's your answer?
Negative infinity, comma 1.
Très bien.
The
Très
one.
bien, très bien, très bien. That's excellent. Excellent. Very, very correct. Has everyone found that answer?
Yes.
Sorry, can you repeat the answer?
The answer, we, TK, we can repeat.
Negative infinity, comma 1.
Okay, so how did you find infinity, negative infinity? Beta means what I can be writing. We, how did you find it? We are solving for this question. We, TK.
Okay, so we start by cube rooting both sides so that we get rid of the
We have
cube root.
x.
The
Root.
Yes.
What to mind at once we have a negative sign which is less than or equal to 1. So we cube root.
1.
You
Yes.
see?
Both sides.
So we're going to cancel this, and we're going to have x we is less than or equal to the cube root of 1. We TK.
Yes, then any root of 1 is equal to 1.
We.
So,
we have
but
1.
then since we have the equality symbol, so we know that when we're finding the coordinates, it's less than or equal to 1. So 1 is the highest this way, so we close it.
We.
And it keeps on going on to negative infinity.
Voila. Yes, sir. Yes, sir. I'm happy again. Very, very happy. Yes, sir. Yeah, you're now getting the concept. It's making sense now, n'est-ce pas?
Yes, yes, it is.
Voila. Just practice. That's the more you practice, trust me. Très facile. Très facile. So, do you have any questions for this part, A2?
Can you kindly explain how the negative infinity is coming about?
Okay, so here we have x less than or equal to the cube root, and we have the cube root that we're going to have here, because it's going to be a fitting object, number value, which is just going to be equal to 1. Okay, so we're going to say the highest value we're going to have, because of this inequality sign that we have here, the highest value we're going to be having for 1, for x is 1. But because we have a sign which is here, at times like majora and minora, we have a sign that is saying x is less than, mean that there are certain objects or certain numbers that we're going to be having, which are, but do we know those numbers? No, on the part, but we have the maximum number that we're having is positive 1. So because of this sign that we're having here, mean that there's an expectancy of us having certain values, small values that we are going to be having. And that's how we put in the negative infinity. We open up. There might be some certain small value that can be contained, but the highest value in this interval is what? Is 1. This set is actually defined in majora. Obligatory is majora. Pardon, minora. Minora. Pardon. Minora. C'est bon?
Oui, c'est bon.
Très bien. The girls,
I have a concern.
you have found the same answer?
Excuse.
Les filles, est-ce qu'on est ensemble? Okay. We go for A3. A3.
Just before the hello.
Number 3. I want the girls to tell me the response for number 3. They have been quiet.
I have a question.
Oui.
On number 1, A1. I think the answer we are getting just an answer we are just from finding at A2. It is satisfying the equation, but on A1 it's not, I think.
Pourquoi?
At A1 we add -1, comma 1. When we put 1 there, which is part of the interval, it is saying 1 is less than 1, which is not satisfying the
No. If we say x is less than 1, are we saying x, the value of x should be 1?
No.
There's no equal sign here. There's no equal sign here. What we are saying here, we're saying x must be less than 1. Okay? But since we have 1 which is already here, the highest number that you can go to is 1. But it's going up to, we don't know any other value that you can have. Okay? But in this case, because we're already going to be using the square root, we just have to look at, okay, what's going to be the square root of my 1 that I'm having, which is the original value that I'm having here. But not really the original value, the interval set that has been defined. The definition of the interval set that you're having is 1. Okay? If I put comme ça, -1 and +1, I'm not saying x is equal to -1 or x is equal to +1. So you cannot put -1 here squared and then you say that's very, very wrong. I told you, Alexa, because x, this x that we're finding here, there's no equal sign here. We can only say that if we have got an equal sign that is here. Okay, that's what has allowed us to write this.
Okay, but since we have opened the bracket with the side of 1, doesn't it mean that even numbers above 1 are part of the interval?
We, but just to know the number. We can't close this interval because of this sign. We don't have an equal sign here, so we don't have the right to close it. We have to open because this is an open interval. You remember interval that you did when you're introducing new numbers, n'est-ce pas? This is an open interval. This is an open interval. No wonder we have got open sets here. You have to go back to your code and get back to that part. On what? How do you represent intervals? Types of interval from an interval to a set to a segment. Okay.
Okay.
You can't close here as long as you have this. Say in Luvare we say tijira. In English, taboo. It's a taboo. In Arab we say c'est haram. C'est haram shop. So, maremo comme ça. J'espère que c'est clair. Oui, A3. I say this one is for the girls. What did you find for A3, the girls? Les filles. Les filles, est-ce qu'on est là? Renzo, you're quiet.
I'm still solving. I haven't found the answer.
All right. Mulenga, you're also quiet.
Can say the same.
All right. And my footballer of the year, the big man Ninde. I didn't even say Ninde. Ninde are present. Ninde.
I'm present, boys.
Ninde have been too quiet. After you got my medal, you even come quiet on me. Can you say something?
Don't worry, I'll say something.
Okay. They are like questions for the girls. Ninde A4 is yours. So I'll be waiting for your answer, Ninde, for A4. Do you have from the list that I'm having here? Kaluva Mutare. Is Kaluva Mutare present? Kaluva Mutare is not present. Okay. We are waiting for the girls. While Ninde is solving A4 and A5 is for the guys. So the guys can even continue solving for A5.
Can I try getting an answer?
We actually.
That would be open the bracket and then in negative infinity, comma 1 and then close.
Okay, negative infinity, comma 1 and close. Okay, that's the first suggestion, Arabia. Anybody else?
That answer for A.
The guys can also come in. Our ladies are still solving. TK, can you put your name there? I don't even know who TK is. Simon, Taisia.
I know for the compound inequality, you're supposed to separate the two inequalities. So if we separate them first, then I'm stuck there.
Try to give me the values that you're finding. I haven't, somebody doesn't exactly answer. I haven't given any answer. I'm open to suggestions. Mike Tembo. Mike has been too quiet. Mike, I'm seeing you. Jabez has also been quiet today. Okay. Renzo, okay, we Changu, we.
Okay, from what Taisia said, I solved them separately, like -1 less than 2x over x squared plus 1. I did it separately, and I solved the other one separately. I'm not so sure if this is what everyone got, but I found x less than -1, and on the other one, I found x less than 1. Yes.
Yeah.
But I don't know where to go from there.
Vous avez réuni. Ah bon, pardon. Vous avez raison. Okay. It's been a very, very interesting question. Let me go back to what I solved.
Okay, can I repeat my answer?
Wait. Can you repeat?
Open. We're going to open the interval. Then it will be negative infinity, comma -1, comma 1, then close.
You're there. That's the way there's a part that you're lacking, but you're almost there. The way you're separating the sets, that's just the point that you're making a mistake. Yeah, you're very, very close to the answer. We need to have a union of something. Which is easy.
From what Changu said, when you reach there, I just tried to find the intersection and gave me -1,1.
Okay. Bon. So this is the response.
-1,1.
Okay. Okay. Are you able to see my screen? Okay. A3. So for A3, so we have from the question that we have 1 minus 2x over x squared plus 1 squared, n'est-ce pas? We get the first part. So I'm going to get one part, we try to solve it, and we can also get the second part. Okay? So I'm going to have 1 minus 2x. Let's go confirm it. Okay? So we're going to have 1 minus 2x over x squared plus 1. We solve for this. We're going to have we solve for this and we simplify with this. We're going to have x squared plus 1 squared minus 4x over x squared. So this squared that we have here, we bring it down, which is equal to, simplify the top part. We're going to have x to the power 4 plus 2x squared plus 1 minus 4x squared over x squared plus 1 squared. We simplify the top part. Now we have 2x squared minus 4x. We're going to have negative 2x plus 1. Voila. We decompose this function. We're going to have x squared minus 1 to the power 2. And we continue having this one. So we say, donc, pour 2x, because I say all x belong to real numbers, on va avoir 1 moins dx, ça, is superior à 0, which actually means to say, because of the composite function here, we have this function that has been decomposed, ça, here, ça, we're going to have x squared minus 1, which is identical, so ça is superior à 0, which implies that x can be part of real numbers with a restriction of -1 and 1, which are the possible values that we can have coming from the question that we've been given. Strictement, ici, strictement. Donc, on pouvait aussi étudier la fonction de f. We can also study this function by saying f of x is equal to 2x over x squared plus 1. On déduit que A3 égale à moins infinity moins A union moins A et moins union 1 virgule infinity. So we can have an infinity set because these can cancel themselves, can have negative infinity up to positive infinity, which is a set that is defined for x. For example, if we have -1 here, we're going to have -1 squared, which is 1 minus 1, 0. So we're going to have 0 over 0 over 1. The minus is 0. Remember, I've got a restriction of not including. We have a restriction of -1 and 1. If we have 1, the meme shows. So we should have a restriction here. We have a restriction that these values that are going to be finding for x should be values that should be greater than -1, less than -1, or rather greater than +1. Mean that they're going to be numbers that are going to be ranging to positive infinity up to negative infinity. And voila, that's how we solve for A3. So it's very, very simple. This is how you answer the question in Analyse. So you solve the question, always be including the donc, on the déduit que pour 2x, tout ça, ça doit être présent. Very, very essential. Voilà. I think you've well, there's Taija said almost the same thing, but this is also where I absorb the question. But as long as you're able to get on with this definition that is here from your answers, c'est bon, c'est bien fait. Or if you want, you can use the function, and then voila, you establish your values of F3. Okay. So you can copy this, you write down, and even on your free time, you can try to go through everything for better understanding.
How did the squared come about? The one which is outside the bracket there, at the first step.
This one?
Yeah.
Okay. Okay. So this square that we have here, it says, bon, because from the question that we have in, okay, let's write it down here. The question that we have in is -1 is less than 2x over x squared plus 1 less than 1. So if you have, I'll suppose this is my artist, this is my, everything that I'm having here, okay, is my b. So it's the same as saying -1 is less than b, which is less than 1. This is equal to what? This is equal to saying b squared is what? Is less than square root of, bon, pardon, is less than 1. Yes, I'm going to define the square because I'm going to have two different values like we had from A. So this is why I actually just did this. Okay, so it's just like describing different of two squares in actual sense. So that's how I established this. That's how the square came about. Okay.
Is there a different way? I'm not satisfied.
Neither am I.
Not satisfied?
Yeah.
Okay. So I wanted to simplify this equation that I'm having here. Okay. I wanted to simplify this equation that I'm having here. So I pause this equation that I'm having here, or the expression that I'm having here is b. So we have what -1 is less than b, which is less than, bon, is -1 is less than b, and 1 is greater than b. Positive 1 is greater than b. This here is the same as saying b squared is less than 1. Okay, because how do you find b? You find b by finding the square root of what? 1. What did we find the square root of 1? We found -1 and what? And +1. So you put this in form of what? In form of an interval. You put this in form of an interval, it's going to give you this. And this is exactly the same thing with this. It's just to try to manipulate things and make things easy as you start solving. Okay.
Is there another way of answering it apart from the same one you explained? Because it's still not satisfying.
Oh. What other way? Let me see.
Yeah, using.
This one is complicated.
Yeah, because what's
Really complicated,
certain is how
but
the squared.
Ah. Bon, how can I? Because this is actually the simplest way I came about to solve it. So I don't know what my fellow engineers want me to, how my fellow engineers want me to solve this equation. Unless I have to sit down and try to find a different way. Unless if there are solutions, otherwise this was actually the simplest way that I thought of solving it with you guys. But since it's not really satisfying, Je ne sais pas.
Excuse me.
Oui.
I would like to find out how the 1 came before the whole equation and to the power 2.
The power 2 is what is here. Okay.
No, the
So,
one in front of the whole interval. How did it come before the whole equation?
here.
Yes.
Okay. So, like I said, we have this, n'est-ce pas? We have b squared is less than 1. So if we get b and take it this side, I'm going to remain it 0 here. Okay. So if we have a 0 here, it's the same as us assignating to be equal to quelque chose. Okay, it's the same as us saying this is less than 0, but don't present the 0 which is this side. So if the b squared comes here, we're going to have 1 minus b squared. What's your b squared? Your b squared is this function that you have here, 2x over x squared plus 1. And that's how we came about this function.
So what you're actually saying is that you just brought back the question before they came to the point where they solved b squared. B squared is less than 1.
Okay. That's what I just did here. I'll just play it with everything that is here. I've actually just been playing with it. So I just decompose this for me to, instead of me finding -1 this side and this other side, I just decompose. You have to find the easiest way that you can decompose the function, okay? Because someone would want to start with solving for when this equation is equal to this and this equation is equal to this. You're going to come up with the same answer. If you start solving with this part, or you solve with, and then you also solve with that other part, you come up with this possible answer. But this is just the easiest way that you can come up with an answer like this, because it's already a defined function. We call it defined function. Okay, so you just have to start thinking. Have to think out of the box, so that you make your life become simple. Or rather, what I'll do is I'll try to resolve it. When we have the next session, I'll use the possible maybe other simple method. I'll try to solve using this. I'll solve it with this part and the other part, and then we can see afterwards. But for today, you can just write down this method and then try to go through it. Okay, c'est bon.
Oui.
Okay. So as you are writing, Ninde, I promised you that the next question is Apple is yours.
Excuse me.
Oui?
I have a question. On the third stage, how did you factorize to get 2x minus 1 to the power squared over 2x? How did you manage to factorize the x to the power 4 minus 2 x squared plus?
I use here is easy here. You use first cos triangle. You know first cos triangle, n'est-ce pas?
First cos triangle.
Yeah, you use 1, you've got 1, 2, 1, 1, 3, 3, 1,
1,
etc.
4, 6, 4, 1.
So you have the highest power that you have in which is.
I'm gonna pass cos triangle.
Okay. So I can use first cos triangle to simplify this. It's very, very simple. And then you can decompose it easily. We all know first cos triangle, n'est-ce pas?
No.
No.
Bon. The next lesson that you're going to have with Mono, tell her to explain Pascal triangle. It's very essential. When you go to your school, they'll be solving questions very fast like that. And then you normally when you have got high powers, for example, you'll be solving a question that has got x to the power 10 plus 2. Okay. So this one, the prof, because this Moroccan them, it's already in their fingers. They already know the values. You are going to have one as the first object, or rather, I'll give an example of so Pascal's triangle in actual sense, this is what helps us be able to factorize very easily. We get to factorize objects expressions very easily. For example, if I have a function x to the power 4 plus 1. So how do I get to factorize this? So you start the Pascal's triangle, which starts with toujours on commence avec 1. You start with 1. So you say 1. Always the first coefficient that you have is 1. So 1 plus 1 we have 2, and always you end with 1. So let's start with 1. We start with 1 plus 2 is 3. 2 plus 1 is 3. Always end with 1. We start with 1. 1 plus 3, we have 4. 3 plus 3, we have 6. And 3 plus 1, we have 4. We always end with 1. So this is x to the power 4, to the power 3, to the power 2, and to the power 1. Okay. So we look at our x to the power 4. So our x to the power 4 that we have is this. So we're going to have x to the power 4. The second coefficient is positive plus the x starts to decrease. We're going to have x to the power 3 plus 6x to the power 2 plus 4x plus 1 that we have there. So this is actually equal to saying x to the power 4 plus just ici. The pas écrit comme ça. Normally it's supposed to be like this. The power 4. Okay, plus x to the power 3 plus 6x squared plus 4x plus 1. So we've actually found the expression for x plus 1 to the power 4. So that's what we use Pascal's triangle for. Okay. Est-ce que c'est bon?
Bosses, there's a concern in the chat. There's something you have to check.
Okay? Mono tells us to find out more from you, and you also direct us to how. Then how are we going to know? But I didn't know she tells you that, so yeah, I didn't know. So it's not that I knew that she tells you that, because you never told me to say Mono has told us to find out this thing from you. So if it's the part that she told you to say find out more from NS, you tell me to say, oh, actually Mono said you should focus on this, or rather Mono said you should tell us this part, because I can't just know that Mono told you that. And even her, she can't really remember everything that she has to tell me, or rather she didn't explain very much to you, because she's teaching like 2 hours, and she also has things to do. So you guys are now that are learning, so you have to tell me, oh, actually Mono said you should tell us more about it, this part, and I'll explain to you. Okay. Otherwise, me, I can't know. I don't attend your course. So what I just tell Mono, I'll tell Mono to say, normally you just do that. I just told Mono to say, oh, okay, I've told this guy that you should explain more on this part, then probably that's what she does. She explains to you guys more. So I didn't know that she didn't explain to you, or rather, because I know it's actually in the code. And I said Mona is going to do that part with you. It's in the code. Okay, so the person, the delete, I didn't know that's what goes on. So you guys should be telling me. Unless you don't, if you don't tell me, I don't know anything. Okay, c'est bon. Est-ce que c'est bon?
A question.
Oui.
When starting to solve this question,
oui.
The original question was like -1 is less than 2x over x squared plus 1 is less than 1. So meaning that you can solve both from -1 is less than 2x over x squared plus 1. You solve it like separately, even like for +1. So like I didn't understand why you only used the +1 instead of both -1.
If you use my method, okay. If you use my method here, if you use this method that is here, b squared is less than 1. You are already going to be solving for -1 and +1 at the same time. Okay, because I've got b squared, you're going to have this part and this part, so you have covered the two parts at the same time. You understand?
Kindly repeat.
I was saying, here you have -1. I suppose this function that is here is b. -1 is less than b, which is less than 1. So I don't want to solve this part and this part. I can solve this together by saying b squared is less than 1. So here you're going to have b, it's going to be -1 and the +1. Mean that you're solving this interval that is here on some. What's that? I'll repeat again. I'll repeat myself. You guys, bon, this part you said it was very it's kind of complex, as supposing and everything. So I said, since you people want me to solve this part alone, and then I do that part, because for me, I solved everything on sum. That's why I said b squared. I brought in b squared is less than 1, and then I went to direct values of 1, because I already know b squared is, in this case, going to be less than -1 or +1. Okay, but since you guys want me to solve this part separate with this the other part, I told you to say you have to give me some time, so I get to type everything and solve it. So the next session that we're going to have, that's when I'm going to develop your method of solving, because I need to simplify everything. I need to make everything easy for you guys by just putting in one by just presenting this squared is less than 1. So David, I think that's David. I'll come back to this question the next time that we meet, okay? Okay. Chango, yeah, thank you so much, Chango, for understanding the concept. It's actually just try to sit down and analyze. You actually get the point why I went to who is that has written to say algebra also says you learn this in Analyse. You people don't talk. So if I don't attend your algebra class, so if you don't tell me to say no, Ernest, you're saving the TD, this person told me this, yeah, I can know. Okay. So I have to be free. If you say no, algebra, he said you should explain this part, because I'm not that is explaining the TD. So it's very, very important that you tell me everything that the other profs tell you to say. In Analyse, you learn this. Okay. Are we clear on that? Don't have to be quiet on me, because I don't know what you're learning. Me, I'm just doing the TDs. C'est bon? Est-ce que c'est bon? Les people. Ah.
Oui.
D'accord. Donc, il faut m'aider. Comedy. Okay, we'll do the last question and then we'll call it a night. Somebody's writing on my piece. I don't know which one that is writing. Well, somebody has been trying to write on the artist on the using their phone probably. So just try to grab it. Go back to exercise 2.
I've got a concern.
Oui?
Yeah, me, the way I've solved that question, I've solved it separate, like the way I was saying. You get -1 less than the expression, like -1 less than b. You solve it separately. Again, when you find the answer, you solve the other one, which is b negative b.
Yes, David.
So I
Yes,
found
David.
both answers.
I'll repeat myself. David, I'll repeat myself on this one. You guys are saying it's possible to solve this part, and then you also solve this part. So I said, for me, I didn't solve it that way. Okay, I solved just by supposing that this part is, for example, B, and then I solved them together at the same time. Donc, qu'est-ce qu'on va faire? I'll solve it the way you guys have solved it. If you have solved it, you can just inbox me. But the next time we meet, we're going to do this question again using you people's method. But I don't want to say your method is correct, because I haven't gone through what you normally before I suggest somebody's method, they have to send me so that I can go through the work for that they've sent me. So David, you send me your solutions, and then the next time that we meet, we're going to have clarity on that. Okay. I haven't said it's obligatory that you should go with my method. Yes, it's clear, David.
Okay.
Voila. So Nindi, A4, what did you find?
I found the same values. -1 and +1.
Hello.
Oui. Ninde.
Hello. I can.
Oui.
All right. So on F4. Okay. So as in F4 is equals to x appartient à R is 1 over the modulus of x greater than 1.
Oui.
Yeah. So I was saying, R it was, yeah, we know that x, it's R at the exclusion of 0. X, 0 can be the denominator there. So have 1 over x greater than 1. So the next step we have the modulus of x, we know that it's x squared, right? So, yeah. So we'll do the x. When we square root 1, we'll have positive or negative. So we'll have 1 over x, the modulus of x greater than 1, it will be equal as x less than 1. So we have the equal sign there. Therefore, since we have x, the modulus of x will be x less than 1 and positive or negative 1. Therefore, we have F4 will open -1 because if we use 0, then we'll make the interval of negative side and the positive side. So we're going to use the inclusion symbol or the union symbol. We say we open.
Voila. Très bien. I wanted that point. Very, very important. Oui. The inclusion of the union. Oui.
Exactly. Then we open, then have the 0, comma 1, then open the other side because we have positive 1 there.
Très bien. Très bien. That's the basic explanation out of Yeah. Thank you so much, Nindo. Very, very.
Sorry, can you repeat just what he was from saying?
So, Mr. Ernest, you can.
Okay. Probably the network wasn't very good. Okay, let me just repeat what you were saying.
Yeah.
Thank you so much, Mr. Nindo. That was fantastic. Let me just explain.
Right.
Okay, so we have the equation, the expression 1 over modulus of x, which is greater than 1. So in actual sense, we have every number. We've got an exception that we have here. R etwa ça veut dire we have got a restriction of what? Of 0, n'est-ce pas? So if we have this, we're able to say 1 is greater than, we cross multiply here. We're going to have modulus of x. This is the same as saying 1 is greater than square root of x. N'est-ce pas? And how do we cancel out the square root? We cancel out the square root by introducing square here, the square there. We're going to have 1 is greater than, pardon. Attention, une erreur. Désolé. Attention, j'ai fait une erreur.
She didn't was it Nindo by name. Tumamba Mose boss, please.
Okay, so we have 1 over x, 1 over modulus of x is greater than 1. So we cross multiply here, we're going to have 1 is greater than modulus of x, and this modulus of x is the same thing as if we can represent this by saying the square root of 1 is greater than x, and let's make an interchange of that. Of course. Okay, this is the same as saying the square root of that. So what's the square root of x in actual sense? So from the definition, from the description we have from Ninde.
Wait, sorry, Ernest. Didn't we say that modulus, it will be x squared, not x, what that one, square root?
Ah oui, pardon. Je pense que je suis fatigué, hein? Pardon, merci beaucoup. Tango, oui. I'm trying to do things very, very fast. Okay. So we're going to have x. How do we cancel out the square root? We're going to have the square root of 1. N'est-ce pas? So what's the square root of, in this actual sense, we're going to have negative 1 and positive 1. Okay. We're going to have this negative x and this your greater than x. Okay, so now how do we have the interval? How do we form an interval in this concept? We have an exception or restriction of what? Of 0, meaning that 0 should not be included. So how do we describe this intersection? We use what we call an inclusion of the union set. So I'm going to start by opening your list value that you're having of x is what? Is negative 1 with an exception of 0. We open union with an inclusion, open 0 and 1, and then we open. Ça veut dire que 0 is not part of the real numbers that you're going to be describing. So this union normally, what we have here is trying to tell you to say 0 should not be part of the real numbers that are going to be actually included or x should not be equal to 0. Okay, so that's how you actually get to present your work. That's how you get to present your work. Okay.
Can you just put the answer on the other side of that clear part
okay,
of
okay. Sorry. We're going to have a -1 to 0. Okay, c'est ça. Est-ce que c'est bon? Are you able to see the answer now?
Oui.
Ok. Ok, ça fait alors. Donc, that's the general concept that we have. Bon, A5 is actually the same. It's actually the same with A3. So since you still had problems on understanding A3, it will be the same thing that you're going to have for A5, because I solved it in the same way. Okay. Changu, your hand was up.
Why has the sign changed on negative? There you've put less than x.
The sign here changes because -1. These are the least numbers that are going to be having. Okay, so you have to change the signs here. You have to it's a very important point to notice. When you're looking at negative, you're looking at every x, the x value should be less. And if you have greater here, you're going to be looking at the x values that are greater. Okay, they'll be the greatest value that you're going to be having for x. That's why I've changed the signs here. Very essential. Thank you for that notice. Very essential. So in this first part, we're looking at the least values. In this part, we're looking at the highest values or the greatest value that are going to be having, which are possibly up to positive infinity. And in this other concept, we can be looking up to possibly negative infinity. The botango.
Oui. But then I've got another question. When exactly do you use the union? Because I thought maybe on A3 it was because there were 2, but then again we use it on A4. When exactly should we combine?
Okay, here we use the inclusion because of the restriction. Because of the restriction that we have here. Okay, a restriction of R étoile. R étoile means except 0. So how do you represent this R étoile except, which means except 0? It's through using the union inclusion. Okay. So in this other sense, it's because we had the positive infinity and negative infinity. If we have infinity here and infinity here, infinity over infinity is what you call forming terminal. When you do limits, you're going to understand that that function doesn't exist. So in this actual sense here, we're saying infinity, x should never be equal to up to infinity, because if it's infinity, you're going to have infinity over infinity. That's going to give you a form indeterminate, great form indeterminate, and undetermined form. That's how again we brought in the inclusion, meaning that except infinity. So if there are exceptions, you have to use an inclusion. Okay.
Oui.
I have a question.
Oui.
Yeah. If I'm getting clearly, you are saying we are using this union set because we have the exception of 0. Not so.
Oui.
So is this why we are even including the 0 in our answer?
Oui.
Okay. Thank you.
Because welcome. Because here we're trying to you don't leave out a 0, because if you leave out a 0, you have undescribed what x value should be. So if you just give me -1 and +1, it's going to be wrong because you have not defined negative. What is the special need of x? X should not be equal to what? What inclusion should we have for x? You have to tell me. Oh, okay, my inclusion that I'm not going to be having for x is 0. Very, very essential.
I have a question as well.
Oui.
You're saying -1 is greater than x, not so? Is less than x, sorry.
Oui.
So if -1 is less than x, so we're talking about x having numbers that are greater than -1. So is 0 not greater than -1 in this case? And we've been told that x, we have an exception of 0 from the real numbers.
Okay. In this, if I got your question very, very clear, is we have -1 is less than x. We are looking at all the possible values that we can have that are greater than x in span. We cannot include 0 in this actual sense because if x is a member of, in this case, if we have x is a member of R at 1, so if we suppose that x, okay, if we suppose that x is equal to 0, we're going to have 1 over 0. What is 1 over 0? It's infinity, n'est-ce pas? Well, you're going to do that part when you start looking at limits. It's actually infinity. Or rather, in normal mathematics, we say it's in undetermined form normally. When you press on a calculator, then give you a possible value, if I'm not mistaken. Okay. So this restriction that is given here, sort of restriction just comes about from nowhere. It's because they already know to say if 0 is part of the answers, if you put 0 as part of your answers, it's going to make an undetermined form here. C'est bon.
So we take it that whenever we're writing that, should we also add the condition to show? Because you said we should also be including my words when solving these things. So when we're doing that, should we just write the exception, our condition for x, what, where it's not showing, it's showing that 0 is not a member of those real numbers? Is it necessary or it's not necessary?
Very, very, very important question, David. I think I told one of your friends, I said it's very, very essential that you talk. It's just because normally if we had this lesson in class, all my solvings personally, I solve them with explanations, like I write every point. You tell the prof, you have to say, on sait que x appartient à R, mais il a une exception que x ne doit pas être égalé à 0. Ça veut dire que si on a 1 sur 0, on va avoir infinity, qui est une forme indéterminée. You see? Alors, then you get this concept that you have. Alors, on peut dire que you write this form that you have here. And that's how you answer the questions. It's very, very essential. So, very, very important thing. When you're solving analysis questions, you have to talk to the professor. Okay, David, very, very important question. You have to talk to the professor. So you have to describe each and every part, every point that you're going to be solving. You have to describe what you're doing. Me, if you solve for me just direct, I just look at it and just say, okay, we just want me to see the answer. But you have to talk to me. Here we do this, here we do this. Every step you have to explain yourself. So that you tell the prof that you have understood what you're doing, okay?
Boss.
Okay, we David.
The part which I didn't understand is where the union comes in. Like I didn't understand the explanation.
I can't get you. I didn't get what you said.
Oh, I was asking you about your explanation, where the union comes in.
Oui. What about it?
Like, how does it come about?
It's when you're making the conclusion. So you tell the professor to say X is not part of, it's not supposed to be part of the real numbers. No what R. So they made the final answer. The final answer to describe everything that you write after you solve everything is this. That's when the inclusion comes in, or the union. Yeah, the union inclusion comes in. It's after you solve.
So now the question is, how am I supposed to tell that this is where I'm supposed to include the union?
Just like the way we solved there. I don't know. You just have. No, I was saying you have to get used for to solve questions. Okay. You have to just get used. That's when you can only. That's when you can know. Okay, this is my final destination that I'm Analyze. Remember I said the first time that I told you guys, I said analyze is a branch of mathematics that you use to analyze. You don't really solve questions, you analyze. Okay. It's just not about solving. It's about you analyzing. So you analyze the situation. Remember sometimes you'll be getting answers, and then you find that the answer that you are actually getting is just an analysis. It's not really the direct answer.
So, boss, the question is, how did you analyze? We also want to get the analysis.
Well, personally, and I analyze this part because okay, I'm kind of used solving these questions. But when you're starting, trust me, it's not really like you're just going to go direct and yeah, be on this. It's about you solving a lot of questions. That's what I'm going to advise you. You have to get to solve a lot of questions. That's when you get to know. Okay, I'm going to end here. Now I'm going to analyze up to this point. It's just don't. It doesn't just come in like just there and then you start getting into the system. No wonder sometimes when you go to school, a lot of people fail because you have to go there. Like the schools whereby you start school today, after 2 weeks you have an exam. If you don't reach such a day, Moroccans already know this one because for them they start this at maybe in grade 9. They already get to analyze things like this. So for you guys, how do you get to be to reach at such a level? You have to solve a lot of questions. Okay. That's the way. You solve a lot of questions. That's how I can just help you. But I cannot just tell you to say this is how you do it. Like it's going to be, I would lie because maybe my method ain't really what's really going to help you. Maybe you can have better methods than I have. But personally, it's because what helped me reach this level is because I solved a lot of questions. I became very, very exposed. I've become exposed when I ask questions. Okay. David, tu as compris?
So this type of questions, do they come in the exam? Or should you just forget?
These questions come. But the way they will come in the form of a question. So you'll be solving a suite and you reach at a point like this. So if you don't understand this point, it's going to be very, very difficult for you to get to finalize everything. These questions come. Every bit of thing that I give you, I know I'm giving you, and I've always been telling you to say, you remember last time we had solved the question like this is the stage that we've reached, then finish it now. Very, very essential. Get every bit of what I tell you, every exercise that I give you, very, very important. So go play. So everything is very, very essential. You'll find this same thing at your school. Okay. Yo, I can't get you.
Another evening class that we have. Are we going to talk about soup?
Sorry?
The next evening class that you schedule, we be able to talk about it with you.
The evening. Well, I didn't really get you. Sorry. Then my network that's not okay.
Can you get me now?
Yeah, I can get you.
Yes, I was asking the next class that you plan like this evening. Will we be able to discuss this with you again?
I'll try to find, like for me this time around, because normally if it's in person, for the past 2 years that I've been teaching Analyse, I normally have a lot of classes. Just to say that I've been very, very busy. Normally I'm not takes Analyse. Yeah, we're going to be having classes. I actually talked because I'll be very, very honest with you and frank. Analyse is one of the most complicated module. Yeah, you can validate all the modules, but like for engineering, if you don't validate Analyse, you can't go anywhere. So yeah, so the people, as they know any better, you should be having humble time with them. You get them into the system as quick as possible. So I'm going to continue having classes like this, maybe once in a week or twice in a week, so that you guys are able to get into the system very, very fast. Because you discover that everything that you do, mechanic du poids, chemistry, what else, algebra, it's all Analyse. So if you don't have Analyse, is the base. It's like the heart of Analyse is the heart of Morocco. So if you don't get Analyse, it's difficult for you in Morocco. That's I'll tell you, that's the reality of Morocco. So me, I'm going to make sure that you guys, as you go to school, you're in the system already. You should be solving questions. That's my mission. So these lessons that I put at night, I think that it's like this is what they do in the 12 here in Morocco. So by the time that you're going to be solving it, the other part, the TDs in Analyse, it will be very, very easy for you because you have already done like the 12 way. It's like you're going for NS. NS normally it's not difficult for part to do pure chemistry, pure sciences, and pure mathematics. That's what I'm trying to prepare you here. It's like I'm feeding you to adapt very, very fast. That's the thing that is here. Okay. So these lessons are for you guys to adapt. Yeah. Yes, this is actually the 12 week normally. This is what they do here in the 12. So that's the thing. So David, trust me, by the time I'm done with you guys, I want one of you guys to call me next year and tell me, Enes, I've gotten a 15 in Analyse. I've gotten a 20, inshallah, in Analyse. I'll be very, very happy. That's why I'm helping you out with these questions. Okay.
So the question is that, has anyone ever gotten a 15 and told you that they got a 15?
We? There's someone got 18 in Analyse. Yeah, I have people that actually, they even took me out actually, just to say thank you. There are a lot of people that have been doing extremely well in Analyse, 12, 10, 15, a lot. So you just have to be one of them. Okay. Okay. Yes, Mulenga. They even took me out. Out. You're surprised. I hope you'll be the one. You'll be the next one to take me out. You'll call me. I've gotten 19.
Yes.
Right. Don't worry. Just follow everything I tell you in Analyse. You'll be successful. You'll be proud. My promise is this. This won't go in vain. This is what I promise you. This won't go in vain. Oui. Renzo, handles David questions. Renzo, I saw your hand up.
I wanted to ask if it is possible to present these answers like the -1, 0 union 0, +1 on the that diagram that you showed that when you are starting.
I present this. Okay, let me try. Bon. If we have three cases comme ça, you're going to have your inlet function that you have. Because you have this something that is better. We have an open set here. An open set, I can just make an assimilation to say I'm going to have values that are going not starting from 0, pardon. Okay. Yes. We have, for example, 1 here and -1. So how do I present something like this? Because I'm looking at the values, a certain group of values. I have values that can range from here, but not really equal to 1. So I'm going to have these values. For example, that's going to be my x here. And I'm also going to have values that can range here. And that's going to be my other x values. Okay. So that's how I can I can represent this set that I'm having here in the form of a Cartesian plane. Okay. But don't worry, there will be no any question like that here. We don't even anything that present this in a Cartesian plane. But I don't really focus on it. Okay. Okay, Renzo.
All right.
Okay. Okay. Yeah. So, boy, it's already 23 hours. Yeah. So, once again, this one going in. Trust me. I can send you results right now. People that have done extremely well in analysis due to the same lessons that I'm giving you. But not one thing that you have to know is not everyone is born. We don't wish for this, but yeah, it's a normal thing whereby people pass, people fail. Something that has been happening. But at least by God's grace, from the time I started these lessons, the number of people that have been passing has been really increasing. And I pray that you just don't become a victim of those people that don't do well, but you should become a victim of those people that call me and invite me for lunch because they have performed very, very well in their first academic year. Yeah. So for those guys that are going to be doing answer, okay, just a quick review. Since this is just not about learning, it's about actually getting to access answer. So this is the thing with answer. For those guys that are going to be doing answer, you have analyze 1 up to analyze 4. Okay. So the key that I'm going to tell you is to validate analyze 1. Analyze 1. Validate this with, whether you like it or not, at least get a mark above 4. When you validate analyze 1, trust me, everything in your semester is going to move very, very smooth. Okay. Very, very important. Validate analyze 1. Because you're going to have analyze 1 in semester 1, analyze 2, semester 2, analyze 3, semester 3, analyze 4, semester 5. But the most complex analysis is analyze 1, which the thing that we're teaching you right now is analyze 1. It's one of the most complex. Okay. So make sure you validate analyze 1. If you just validate analyze 1, surface, things become very, very easy for you. Same thing that people are going for GGM, MIPC, BCG, yeah, that's FST. All those people that are going for FST, it's the same system. You have analyze 1 up to analyze 4. Very, very important also. Make sure you validate analyze. Surprise us, so validate analyze. Business, same thing. Mainly business, you find, it's very, very weird. There was someone actually sent me a result. I think that was for first year, yeah. One of the people that I taught last year. Imagine somebody gets comptability accounts, somebody gets 16, other modules 14, and then the person got a 2 in analysis. I was very, very heartbroken. Even though the person never used to come for lessons, because for her she thought, no, the analysis is easy. She got a 2 in analysis. Imagine you get all these good marks, but you can't go to second year because you failed analysis. It really hurts. It really, really hurts. So you have to be very, very serious. You have to make sure at least minimum analysis should come at least it's a 12. That's the minimum. That should be a mission. Okay. I can give you results right now whereby somebody got 19, no, not 19, not somebody has not yet gotten 19, but at least we've had one person that has got 18 in Analyse. We have people that have been getting 14s, 12s, 10s. So surprise us and get a 19. Safi. Safi. You solve this person that got 18. I would have given names, but you start inboxing them to say, how did you do it? So we'll just keep it here. Okay. So the heart of Morocco, of school in Morocco is Analyse. This is the heart. The first year we just wanted to do Analyse and algebra, but we just include these other modules. They're not really complicated because the main heart of math of school in Morocco is this same animal here. So you're able to feed it stuff, your life goes well. So make sure you spend a lot of time solving a lot of different things in Analyse. Trust me, you are not going to go, you never go wrong. And I'm always here to help you guys. Yeah, I'm always at your service. Just make sure you become the perfect people. We are here for school, so I'm always here to help you guys to become the
We're
perfect.
having class in the morning.
Sorry.
Oh my
Ah, okay. So do you have any questions? I'm done. Do you have any questions? Any questions, concerns? Are you having any problems so far?
Okay, boss.
Sorry, I didn't get you. There's someone that has said that calls for taking it slow and moving on some. We are not rushing for anything. I'll tell you something very, very important. The thing that is here is you all have different schools. Okay. So there are people that are, for example, going to do for the engineering people, like normally for Analyse, for the engineering guys, those people are supposed to do a lot of topics for them to get to adapt very, very fast when they go. Okay. No wonder we have what we call a one-to-one professor and student moment, whereby if a student comes to me and says, Ernest, I'm behind here. I explain to you on your free time. Okay. We are rushing for this. We are saying rushing for no. We are actually rushing for something. We want you guys to be well fed, to be well baked. Okay. So if you have any problem, whenever we say we have any problem, it is online. Just tell me, Ernest, I have a problem. Call me. No matter, I have too many messages. So just call me, Ernest. Can you please arrange a rendezvous? I need to understand this part here. You paid for Zoom, so Zoom we can schedule any meeting. And then there we are. I'm going to be solving questions. You see, but sometimes when we are solving questions very fast, it's because we have to cater for everyone. We cater for everyone at the same time. Okay, so squared, it's not like we're rushing for nothing, rushing for something, because we know what we're rushing for. We have the experience already, so you get to understand this next year. Like, this is why Mono or SL or NS we're actually putting in all those efforts and very, very fast. But still will play. If you don't understand the concept, sometimes you just don't understand when you're in a group. You can call me, you can get to me, give it to me, and then voila, I'll be here to help you guys. Or are there to help you guys. Okay. I hope okay, somebody said the timetable is too tight. But that one you can't do anything because you guys will stop learning by the 10th, or 15th of next month. They have to be free up to October. So just give it 1 month. 1 month, like a pressure here. It's going to pay off, trust me. Don't worry about it. The timetable is okay. You guys are going to school from 8 hours to 18 hours when you go to your school. We're just trying to get into the system. So that one is a squared. Yeah, for now, it's just 1 month. You already used 2 weeks. So just wait for the other 2 weeks. We teach you, we'll leave you. Yeah, you prepare for school. So the timetable can't really do anything. Any other concern?
I know how good I was in math back in Zambia.
Okay, but I think to me the time to see 12 is very, very late. Actually, my lesson has ended. Unless if there's anything else to say before I anything?
Okay, I think I took additional mathematics when I was in high school. I took the normal mathematics.
Okay.
Yes.
If there's nothing, bon. Merci beaucoup pour venir. I'll organize a meeting very, very soon. And then we will continue to solve together. You're welcome, Mr. Lauren. You're welcome here to make sure you guys are well baked. We continue to work together. Thank you so much. Bonne nuit. Merci beaucoup.
There was a guy from